ఆదివారం అదే సెలవు దినాలు కూడా రేట్లు పెంచారు.
All right. So OSI model. So this is open system interconnection model, and this is like layers. Okay. This model is like a blueprint for how computer networks should communicate with each other, of course. Not only computer network, like even end-to-end communication or packet transaction, everything basically is designed based on this blueprint. It divides the complex process into smaller, manageable layers, each with its own specific role. And that's how it makes us understand how communication or data transaction takes place. We'll start from the very first layer, which is the physical layer, starting from the very bottom. There we go. Physical layer, the first one. It's the foundation of the tower. Consider this as a tower dealing with physical connections. This we would talk about cables and any hardwares whatsoever, and raw data transmission. It handles electrical signals, cables, and network hardware like switches and routers. So switches and routers are those devices which actually help you connect with the internet. Your ISP installs one at your place.
Please, are you sharing the screen? I can't see anything.
Really? Okay. I don't know. Is it visible now?
Oh, yes, yes.
Oh, all right. Okay. Hmm, I see. It was paused for some reason, but anyway. All right, moving on. Yeah, so it's all about moving bits from one place to another. So here, the communication is taking place through cables or the hardwares. Okay, so in the very first layer, we define all the available communication channels. These are communication channels through which your communication is going to take place. Either you're going to use if you're on a local connection, right? If you're in your home and this is your router and you got some devices over here, like four of them, all four might be connected with either with a wire, we call it a wired connection, or it could be a wireless connection like a Wi-Fi or something. So it's either going to be one of those. So the channel definition is given at the physical layer, what kind of communication is going to be there. After which, on layer two, here we take care of linking devices on the same network. Now, to identify a device in a network, okay, let's say this is your computer network, this is your router, and these are two devices, device A and device B. To identify these two devices individually, you know what, I'm gonna make it bigger. Hold on. Yep. Okay, better. Device A and device B. To identify these two devices as unique individuals, they're gonna have two kind of identities. For example, you have a very simple identity called your name, right? But two people can have same name. There will be, I don't know, maybe a million people with my same name, Akash, or there could be a couple of billion people with the name Chris. So the point is, name cannot be a unique identifier because anybody can have it. We have unique identification like fingerprint, right? So these two devices also have two different kinds of unique identification. The first one is called a hardware ID, and that's called a MAC, right? So a MAC is basically media access control. That's MAC, media access control. This Mac is actually a hardware. It's a piece of hardware that installs on your computers so that through which you can connect to the internet in general. Your computers cannot connect to the internet without a Mac card, okay? Actually, Mac is an identity which resides in a specific kind of a card called NIC, which is called the Network Interface Card. Network Interface Card. This card is a hardware that installs on your computer, and this card have an identity called Mac, right? That's what Mac is. Mac helps your hardware to be identified uniquely. No two devices, no two piece of computers will have the same MAC address. Every system will have a different MAC address for sure. They will never be the same, by the way. And that's how they are uniquely identified, all right? In addition to this MAC address, there's also another one, another identity that also helps us identify systems separately. And it's called IP. So IP is a network identity, short for the Internet Protocol. So if you see at the word protocol, basically it is a list of rules. Protocols are rules, right? So the rules to use the internet is actually IP. And these rules also give you a certain kind of an identity, which is an IP address. It gives you an address. So MAC is a hardware address and IP is a network address. What we have understood is device identities, the two kinds of network identity and the hardware identity. Network identity is the secondary one, hardware is the first. In hardware identity, we talk about MAC addresses. Network identity, we talk about IP addresses. MAC is short for Media Access Control, which is assigned to NIC, Network Interface Card. In your like desktop computers, it looks something like this. I'll show you. See these kind of cards like that have the Ethernet port in which you just like plug in the cable. So that's the NIC card. This card have a unique identity which is called a MAC address, media access control address. This card is unique to all devices, all right? no two devices will have the same MAC address for sure. All right. So they can be identified like separately in a network. On the other hand, an IP address is the Internet Protocol address, which is provided to you by your router, assigned by router in a LAN connection. And if you are connected to the internet, it is assigned by ISP on internet for internet. It's assigned in two different ways. If you're using your computer in a LAN connection or local area network, then it's given to you by your router. But if you're using, if you talk about the internet IP, that is given to you by the ISP, your internet service provider. These two identities are always going to be unique to every device. No two devices will have the same. So if you will go by the layers, the second layer clearly mentions, see, in these two devices, like let's say my computer is going to start a data transmission. So my hardware will act first, and then I will do the activity of network, because the actual data is going to originate from my hardware, right? Because the data is being originating from my hardware, as per the OSI model, the first thing that will be identified is my hardware. And that's what happens on the data link layer. It uses MAC address to ensure data reaches the correct recipient. This layer also handles error detection and retransmission if data gets corrupted. So this confirms who is going to get the information. So the MAC address verification will take place on layer 2. It takes place earlier because the data is originating from the device and it's going to be given to a device, right? So that's how it is confirmed. Like, okay, this is the device who's going to get the data that is being received, the recipient, right? All right. After that, on third layer is where we confirm the IP address. It focuses on routing. It uses IP address to deliver data across different networks. So if it's going out of your network, let's say you were sending some text message or email to me, or we're talking on a chat application on our computer, then definitely that kind of transaction will require to confirm IP address. And that's exactly what happens at third layer, the network layer. First confirms the device. Okay, you got all the connections in place. In second layer, you talk about, all right, the devices are confirmed that this is the device who's sending it and this is the device who's going to receive it. A and B, basically. Then it confirms the network, like if they are like having the proper IP address or not, if there's any resolution that needs to be provided, or if there's any channel specifically that needs to be taken in order to reach the recipient. In the transport layer is where we talk about data transmission. This layer ensures data is delivered smoothly and reliably. It breaks data into smaller chunks. So let's say if this is my piece of data, right? This is some random data, all right? Some secret message or kind of something like that. It could be a piece of string, it could be an image, could be a audio recording, could be literally anything, does not matter. What will it do is it breaks it down into smaller chunks. Because let's say, let's just say in my communication, these many data packets are supposed to be sent. These many of them, all right? There could be a million of them, right? Imagine if 2 packets gets missing. What happens is the data consistency is now compromised and there is no reliability anymore, because I cannot confirm that if all the files were received or not, and if all the information was delivered correctly or not. And that is my biggest concern. And this is why, instead of sending a whole chunk at one time, it divides it into smaller chunks, sends it one by one, right? And this is being sent by A. When B receives it, it joins all the chunks back and gets the actual data packet that was sent in the first place. The same data packet is being organized on B, which is the recipient. Right? So that's how the transport layer helps in a network communication in order to send and receive data. It's like splitting a big message into smaller envelopes to make sure everything is received and nothing gets lost in the transit. In layer 5, we establish a session between the two devices. So this is where the communication session is being established between A and B. We establish, manage, and terminate
Sorry,
connection.
I have a question on the transport layer.
Yeah, go ahead.
TCP and UDP occurs at the transport layer.
Yeah,
Am I-
that's correct.
Since UDP
Does not breaks in chunk, and UDP have an exception on transport layer. It sends the data packet all together instead of breaking it down. So yes, your concern is correct.
yes, what I'm saying is this.
Mm-hmm.
Since UDP is not reliable
Mm-hmm.
of like TCP,
Uh-huh.
so are we going to say like from the statement here that it ensures there's a place I saw that the layer ensures data delivery is smooth and reliable. That's where I'm asking the question.
Mm-hmm. Okay, let me tell you something.
You
See,
understand what I'm saying?
yeah, go. I'm sorry, come again.
What I'm saying is that reliable? That's what I'm asking.
Yeah, got it. Yeah.
UDP is not
Okay.
as reliable as TCP.
Just to give a context of what you're asking. So TCP is
Connection oriented.
TCP and UDP are two protocols basically. Right. These protocols are responsible for communication of packets in different formats. They have both certain kind of you can say regulations through which they transmit the data. TCP is transmission control protocol, whereas UDP is user datagram protocol. In short, how they work is TCP breaks down data into smaller chunks and reassembles the data on recipient. That's what it does. Due to this breaking down of data and reassembly, it's a little slower, but it's more reliable because it makes sure like all the data is being received on the other end. Talking about UDP, on the other hand, it sends the data in chunks. And on the other hand, unlike TCP, because it's sending data in like bigger chunks, it's faster. Now, the problem with this one is it's not reliable. And this is because of loss of packets. But we cannot say that UDP is useless. The reason is because in certain kind of communication channels, we need a UDP kind of protocol because let's say talk about video connections, right? Like right now, I am transmitting my screen to you. This is all coming through a UDP channel because large amount of data is being sent at one time and it's more faster. You don't want a slow video transmission, do you? Like if I say something right now, you need to hear it right now. What if you receive it maybe a second later? Then there will be a lag, as we call it, right? So you don't want those lags or buffering issues, basically. So UDP is amazing for video streaming, gaming, right? For all that kind of stuff, UDP is great because even if you're video streaming and some packets are lost, you will still be able to see the transmission a little clearly, right? The packets might be pixelated or something, but your video streaming will continue. But if I'm sending you a video file, I don't want that to happen, right? I want you to receive the file in its intact format. And for that, I'll prefer TCP because even if it's slower, it's reliable because it's going to send the whole thing all together. Now, the transport layer, of course, does the same thing as TCP. As you can see, it breaks down into smaller chunks. But it does have an exception for UDP. UDP and TCP both work on transport layer, but UDP act a little different on transport layer. It acts the way it is supposed to act. Okay. But you cannot say that it is unreliable. It's just that it is, I won't say it is not reliable. There is a loss of packets. That's it. But it is reliable, of course, because it is being used on multiple occasions for multiple purposes. Even in fingerprint scanners, you know, at your offices, you must be having some fingerprint scanners. They use UDP protocols all the time. So for that kind of efficient and faster transmission, you need UDP. So you cannot literally like completely ignore that. But yes, they both work on transport layer. They both work in a separate fashion. Majority of your data communication goes through TCP. You're sending files, messages, whatever is happening, it's happening through TCP. UDP use cases are very fewer compared to TCP. But yes, it is also a very efficient one, frankly. It works quickly and it is usable wherever it's required. I hope I answered the question. Moving on to the next one is the session layer where the session is established between the two devices. This layer manages the communication channel that is open. It manages like when the session is supposed to be terminated, how it was initiated, what kind of checks were going on. It's like opening and closing doors for communication, making sure everything is sent and received. So this session layer will manage the communication line between the two devices that are being sending and receiving the data. Now, these two final layers, I call them the user layers, okay? These are user layers because in presentation layer, it's focused on how data should be presented, like what kind of format of data is being delivered or received. Is responsible for translating data into a format that applications can understand. Think of it as a translating different languages so everyone can communicate easily. So whatever data I'm sending to you, it might be converted into a certain format and then being sent to you. So the presentation layer makes sure that your computer and you can understand what is being delivered because whatever is being delivered could be in binary format, right? You know, the binary format is like zeros and ones. So all that there are more different kind of encryptions going on or cryptographic algorithms are running, or if there's any conversions like binaries or octal. So all those kind of translations are done at presentation layer. So on the user end, it works more efficiently and gives more comfort to understand what is being sent or received. The application layer is finally when you are operating on the data packet. This is the top floor where all the user applications reside, like your emails, your web browsers, file transfers, softwares, and much more the other stuff. This is where you interact directly with the network and use the services provided. So if let's say you are on a browser, okay, and you're using any kind of a website or something, the first protocol that you'll come across is HTTP, which is Hypertext Transfer Protocol. It's basically used for web application-based communication. It's This protocol is basically a set of rules that governs the communication between web servers and web browsers. All right. So HTTP is the first protocol that come across when you are surfing the internet, right? So browsers will reside on the application layer, but you see, before the browser actually comes in action, all these 6 layers have already done their work. So you see how efficient that is and how fast all this takes place. So before the browser comes in action, there's like 6 more layers in action already, all the time, by the way. So these 7 layers actually makes up the whole internet communication possible for you, and it makes it more efficient and user-friendly. So that's why OSI model is very important to understand. And that's its job, basically, to make your communication possible. That's OSI model for you. These layers are simple to understand. There's not such rocket science. It's if you just like get the chronology right, and if you understand like which comes first and what exactly job they're doing, then it's easier to remember because this is a very simple. This is a very like favorite topic for an interviewer to ask you from. I can maybe make I don't know 50 different questions just based on OSI. I can give you conditional based questions. I can give you practicals, or just to get a case study out of it and maybe help to you see, OSI model helps me understand that you, as a cybersecurity engineer, understand the fundamental. You know how network communication is taking place, right? And you know where to strike, when to strike. So let's say if I'm going to talk about session tokens or user tokens, right? Which or user ID tokens, something like that. Then you know that we're going to talk about session layer, right? If I'm going to talk about identity management, we might talk about the layer 2 and 3. If I'm going to talk about data types or formats, you know, you're going to talk about presentation layer. If I'm going to talk about endpoints, then we will talk about the application layer. So there's a lot of things that also are involved along with this, obviously. But yes, understanding OSI model helps you understand communication much better. So that's what OSI model is. I'm going to share this whole thing with you, this document. So don't you worry about it. It got some more fundamentals of networking, like what is a network device, what is a router, cables. I'm believing like you know this all stuff already. What's a router? You know it. It helps you connect. I mean, of course, in this course, I'm not going to teach you what's a mouse and a keyboard and a speaker and all that. Those are like pretty basic stuff. You're using a computer, you know it by now what those things are. So I'm not going to go into that basic, but yeah, you get the idea of like what OSI model is. You know what the devices are. Yes, Chris, we will talk about that maybe in topic where we'll discuss about wireless communications more efficiently. This will not be the right time to discuss that because it will like totally derail from what I'm going to teach you next. Right? Okay. So here I'm gonna boot Kali because we're gonna do some action over here. I'm gonna teach you two new stuff. First will be how to scan your network and how to manage your MAC address in your device. Let me show you that. I'm gonna boot my Kali. You guys can do that too. That will be better. And I'm hoping by now you all must be having the Kali Linux installed and updated.
Yes, I have my installed and updated.